Hello friends, this is Jim with Science Talk. I have a story from space, and this involves pulsars. This newfound X-ray pulsar is orbiting its partner at record speed. A powerful X-ray pulsar is whipping around its stellar partner at record-breaking speed. This is according to new data from the Neutron Star Interior Composition Explorer, or the acronym NICER. This is a machinery system that was installed aboard the International Space Station last June, and these two stars revolve around each other once every 38 minutes. Well, that is whipping around. This is the fastest orbit ever observed in a pulsar binary system. Of the two stars, one is an X-ray pulsar, which is a super-dense neutron star that shoots out X-rays as it spins. Now, there is an interesting thing, and sorry, I'm going to have to pull in some little vector calculus in here, but there's a thing called the curl of a rotating system. So a curl, something like, say, spinning in this plane. Well, when you multiply two vectors, the resulting vector is orthogonal, meaning it appears at right angle to the two vectors that were just crossed. Now, I just mentioned briefly when I showed you what's going on off Greenland, that vectors are quantities that contain a scalar component and a directional component. You have magnitude and direction. Well, when you have the curl of a system, something is a body that's rotating. As it's rotating, you're curling. Right? Remember the old right-hand rule? You're curling this way. The resulting vector is going to be orthogonal to the plane of rotation. So if a pulsar is spinning this way and is shooting out X-rays, the X-rays are going to come out basically from the poles. Because if it's spinning, let's say it's spinning around its equator, what's orthogonal to the equator is the main axis on which the object is spinning. That's where the X-rays are shooting out of. So it's coming out the poles. So it's spinning like so, and it's spinning that way. It could be spinning this way, and it will still come out that way. Okay? So it's a straightforward, basically, vector analysis concepts. So to keep that in mind, that it's shooting out these X-rays, the X-rays are going to be basically coming out orthogonal, also called normal, called perpendicular, called right angles, to the direction of rotation. So pulsars form when massive stars explode in a supernova or kaboom, leaving behind a basically spinning stellar core. This particular pulsar is known as an accreting millisecond X-ray pulsar, or AMXP. The pulsar, called IGR J17062-6143, or J17062 for short, is closer to its partner star than Earth is to its own moon. That is close. Because of how close they are and the extreme speed at which they're traveling, it's not possible for a hydrogen-rich star such as our Sun to be a pulsar's companion. You can't fit a star like that into such a small orbit. Not to mention the gravitational effects and ripping out all the material and so on. So that statement about not possible for a hydrogen-rich star, such as our Sun, to be a pulsar's companion, was made by the lead study author, Todd Strohmeyer, who is an astrophysicist at NASA's Goddard Space Flight Center in Maryland. So, because you can't have a hydrogen-rich star as its companion when it's so close in proximity, they concluded that the second star is likely a hydrogen-poor white dwarf. White dwarf stars are small, dense stars, typically about the size of Earth, and they form when low mass stars go through gravitational collapse. And you got brown dwarfs and all that kind of stuff, but they're thinking it's a white dwarf along with an X-ray pulsar, basically. The discovery of this system was supported by earlier observations made by the Rossi X-ray Timing Explorer in 2008. Because NICER has been able to make observations for longer periods of time, the team can now confirm the record speed of this rather unique pulsar binary system. As the two stars revolve around each other over time, material from the white dwarf donor star will build up on the pulsar. Pulsar will have a stronger gravitational attraction. If the pressure of this buildup increases to the point where its atoms fuse, then J17062 could explode with the energy equivalent to 115 megaton bombs detonating over every square centimeter. Not just total, every square centimeter. That's quite an explosion. Strohmeyer says, Pulsar has not quite gotten there yet. So, by studying neutron stars such as J17062, the system there, scientists can, actually that's a pulsar, not a neutron star, I misspoke there, it's a pulsar. So by studying the pulsar, I guess pulsar is a type of neutron stars, that's right, that scientists can examine the elements of the subatomic physics in ways that you can't do in man-made laboratories. So basically this will allow scientists to better understand what these stars are, how they behave, and so on. So you have a neutron pulsar object in a tight formation with a white dwarf, and orbiting each other very quickly, once every 38 minutes, and all sorts of materials is being yanked from the white dwarf onto the neutron slash pulsar. And stay tuned to see what happens. So, thank you for your time, and we'll talk soon. Hey folks, just a reminder to please subscribe and click the bell so you know when I drop a video. Please share my videos, please tell others of my channel and of the work that I do. I also hope that you will consider becoming a patron at patreon.com/Science Talk with Jim Massa, where from time to time I upload videos there exclusively for my patron subscribers. Details in the description box below. Thanks.